we're getting towards what you've been waiting for, some shortcuts. All right, remember that derivative f of x represents the slope. Right? Derivative f of x is the slope or rate of change of a line tangent to f of x at any given x value. Below we have two linear functions. F of x right here is 3x minus 4, and g of x, this function right here, is just 6. It's a constant function, but it's a horizontal line. What's the rate of change, or the slope, of f of x at any given point on the graph? So we want to know, how is it changing no matter what point we're at? What's the rate of change at that point? Well, for a line, the rate of change is just the slope. It's changing at the same rate all the time. So in this case, the derivative of f of x is always going to be 3, because we're going up 3 over 1. Up 3 over 1. Every point has the same rate of change. It's always changing at the same rate. What the rate of change is the slope. These are interchangeable like we've been talking about before. This, remember, function f of x equals 3x minus 4. Our slope is 3. Our derivative is going to be 3 all the time for this line. Now, for g of x, what's the rate of change or the slope of g of x at any given point on the graph? Hopefully you guys all shouted out 0. Derivative of g of x equals 0. Slope is 0. It's a horizontal line. There is no rate of change. It's constant. It's staying the same the whole time. That's why we call it a constant function. It's not changing. It's always 6 no matter what. So from these, we can kind of look at our first two shortcuts of derivatives, where we don't have to do the whole limit definition of a derivative that we've been doing and having so much fun with. The derivative of a linear function, if we have f of x equals mx plus b, well, our derivative is just m. It's the slope. Slope is always the same. Rate of change is always the same. The derivative of a constant function, if we just have f of x equals some constant, some number, then the derivative of f of x is going to be 0, because that's a horizontal line. And a horizontal line has a slope of 0. So take a look at these problems down below, 1 through 6. We'll look at a couple together, and you can figure out the rest on your own. For number 1, we want to find the derivative of f of x if f of x equals negative 4x plus 2. Well, it's a linear function. Our derivative is going to be the same as the slope of our line. So it's just negative 4. If we look at number 3, find derivative of f of x if f of x equals negative 5. That's a constant function. So the derivative of a constant function is always going to be 0. All right, I want you to take like 30 seconds to do the other 4. All right, let's go ahead and take a look at these. Okay, here are your answers. Take a look. Number 2 should be 2/3. 4 is negative 5/3. 5 is 0. 6 is negative 3. Now, even though 4, 5, and 6 have a number in here, we're finding the derivative at a specific value. In these cases, it doesn't matter, because for linear functions, the derivative is always the same. It's never changing. We always have the same slope. That's something that we'll find is not always true with other functions like quadratics and cubics.